Hi Flashes, so today we are going to be talking about comparing and ordering rational numbers. So just like we talked about yesterday, whenever we see fractions or some square roots, we always want to try and change them into decimals or their whole numbers because decimals are just a lot easier to compare and order than looking at fractions or some square roots and all of those, okay? So let's look at the first one. So we have 2/3 and 5/8. So again, if you don't know off the top of your head which one's bigger, which one's smaller, how about we change them into decimals? So if you guys remember, to change anything to decimals, we have to divide, okay? And when you divide, you always take numerator divided by denominator. So in this case, I'm going to take 2 divided by 3. So when we take 2 divided by 3, 2 goes on the inside and the 3 goes on the outside. So now we just need to say to ourselves, okay, can 3 go into 2? No, it cannot. So if it can't, you add a decimal point and you add a 0. And then now you're saying, okay, 3 goes into 26 times. So that's 18. And I get a remainder of 2. So once again, 3 does not go into 2, so you add a 0. And if you notice, I'm just going to keep again. So 2/3 is the same thing as 0.6 repeating. So I'm just going to put that down here at the bottom, 0.6 repeating, okay? So now we're going to do the same thing with 5/8. So we're going to take 5 divided by 8. Again, your numerator is always the number that goes on the inside. So then you just need to say to yourself, okay, does 8 go into 5? Nope. So if it doesn't, you add a decimal point and a 0. So I'm just going to move my decimal point up there at the top so I don't forget about it. And then now you say to yourself, okay, 8 goes into 56 times, because that would be 48. Get a remainder of 2. 8 does not go into 2, so that's when you add your 0. 8 goes into 22 times, because that's 16. 8 does not go into 4, so add another 0. And then 8 goes into 45 times. And then 8 goes into 45 times, and then I get a remainder of 0. So 5/8 is the same thing as 0.625. So when we are trying to compare decimals, I always have my students line them up. So 0.6 repeating, so 0.666 and so on. And then 0.625. So if you're trying to figure out which one's bigger, you just have to look at each position that your numbers are in. So your first position is the tenths place. So if you notice, these are both 6s, so that is not going to help us. So then you move on to the second column. In the second column, you notice that we have a 6 and a 2. So which number is bigger, 6 or 2? 6s, right? So if 6 is bigger than 2, that means that this whole decimal, the 0.6 repeating, is greater than the 0.625. So you need the inequality symbol, I always like to think of it as like a gator mouth, to be chomping up the bigger thing. So in this case, the 0.6 repeating is bigger than 0.625, so you need the alligator mouth, or in other words, the greater than symbol that opens up towards that 2/3, okay? Alright, so next one, notice how they are already decimals. So again, if you don't know which one's bigger, try lining them up. So we have 0.03 and then we have 0.003. So once again, you're looking at the position. So in the first position, in the tenths place, they're both 0, so that's not going to help us. So then you move on to the next column. In the hundredths place, we have a 3 and a 0. So which number is bigger, 3 or 0? Well, 3 is, so that means that this decimal is going to be bigger than the 0.003. So again, since 0.03 is bigger than 0.003, I'm going to have that greater than symbol pointing or opening up towards the 0.03. All right, next one. Once again, we have decimals, so we don't have to change anything. I'm just going to line them up. So I have 1.1 and I have 1.05. And notice when I say that I'm lining them up with their decimal points, okay? So that once again, I can look at each position to figure out which one is greater than the other one. So looking at the ones place, I have 2 ones here, so that's not going to help me decide which one's bigger. So now I move to the tens place, and I do see that I have a 1 and a 0. So since 1 is greater than 0, 1.1 is going to be my greater than number. So once again, I'm going to have another greater than sign. All right, moving on to number 4. Notice how I do have a fraction and a decimal. So I want to change that fraction into a decimal to help us out. So 2/5. Remember, you're taking 2 divided by 5. So your numerator goes on the inside and your denominator goes on the outside. So now we can start dividing. So does 5 go into 20? Or sorry, does 5 go into 2? Nope. So that's when you add your decimal point and the 0. So that now 5 goes into 20 4 times. And you do get a remainder of 0. So 2/5 is the same thing as 0.4. Okay. So now that we have 2 decimals, we can start lining everything up. So I have 0.4 and I have 0.44. So again, you're just looking at each position. So if you look at the tens place, you have 2 4s. 4s are not bigger than each other or less than each other, so that's when you move on to the next column. If there is an empty space, you can always fill in a 0 because 0.4 is the same thing as 0.40. So that now you guys can figure out, oh look, 4 is greater than 0, so that means that my 0.44 is going to be my greater than number. So you want your inequality symbol, in this case is going to be the less than symbol, that's opening up towards the greater number. Alright, so the next one we have negative 2.75 and negative 2.5. So negatives, remember, are a little bit trickier because you have to think opposite. So whatever the greater number is, that's going to be your least number. So in this case, we have 2.75 and 2.5. So looking at your position, notice how 7 is bigger than 5. So technically the 2.75 would be bigger if it was positive. However, both of these are negative. So since they're both negative, I'll show you what it looks like on the number line. So let's say this is -1, -2, and -3. If I were to plot these on the number line, negative 2.75 would be closer to 3, and then negative 2.5 would be right in the middle of -2 and -3. So we want to look for which point is closer to 0. So the point that's closer to 0 is -2.5. So this number, the -2.5, is greater than the -2.75. So again, whenever you see opposites, you kind of have to think different than if it was positive. So if these two were positive, then the 2.75 would be the greatest number. But since they're negative, it's actually the smallest. Okay. Alright, and then number 6, -3/4 and -0.75. Once again, you are trying to change this fraction into a decimal, so let's do that first. 3 divided by 4. 4 does not go into 3, so that's when you add your decimal point and a 0, and you shoot that decimal point straight up. And now you're trying to say to yourself, okay, 4 goes into 37 times. 4 does not go into 2, so I add another 0. 4 goes into 25 times. And that's where I get my remainder of 0. So -3/4 is the same thing as -0.75. And if you notice, we have the same exact decimals. So our inequality symbol that we need is the equal sign. right, now when it comes to square roots, yes, you could change these if you wanted to. However, the easiest way to do this is, well, first, there's no negatives, so we're only dealing with positives. But whichever number is the biggest on the inside of the square root is going to be the biggest number. So, for example, is 25 or 24 bigger? 25 is. So guess what? The square root of 25 is greater than the square root of 24. How about these two? Square root of 13, square root of 29. Which number is bigger? 29. So square root of 29 is greater than square root of 13. And then the last one, 16 is greater than 15. So the square root of 16 is going to be greater than the square root of 15. Okay, so we are still going to use the same logic to order rational numbers from least to greatest, okay? So, very first thing that we are going to do is change everything to decimals if we can. Change all square roots to their whole number, or trying to figure out where that square root will fall in between, okay? So, for example, looking at the first one here, square root of 16, we do know that there is a number times itself that would give us 16, and that number is 4. So I'm just going to rewrite the square root. So I'm just going to rewrite the square root of 16 as 4. Then 4 2/5. So I see a fraction, so I want to change that to a decimal to make it a little bit easier for myself. And if you guys remember, up here we already took 2/5 and made it a decimal, and that was 0.4. You just need to add on that whole number as well. So 2/5 was 0.4, but we still have that whole number 4, so this fraction is going to be 4.4. Notice how 3.4 is already a decimal, so we're just going to leave it as 3.4. Then we have 3 2/10, so I do want to change that to a decimal. So that is just taking 2 divided by 5. Oh, sorry, 2 divided by 10. Okay. So 10 does not go into 2, so that's when we add our decimal point and a 0. And then 10 goes into 20 2 times. So 2/10 is the same thing as 0.2, which means that 3 2/10 is the same thing as 3.2. Alright, and then remember this last symbol is pi. Remember we represent pi as 3.14. Okay, so once we have everything into decimals, I would maybe go ahead and start lining them up to help us out a little bit more with where our numbers are going to be placed from least to greatest. So we have 4. Remember that there is an imaginary decimal point at the end of 4, so 4 would be like the same as 4.0. We have 4.4, 3.4, 3.2, and 3.14. So we want our numbers in order from least to greatest. So look at the first column. Are 3s or 4s less than each other? So is 4 less than 3, or is 3 less than 4? 3 is less than 4. So I don't want to look at these two yet, so I'm going to leave those for the end. Now I move on to the tenths place. So I have a 4, a 2, and a 1. So which one is the smallest? The 3.14 is the smallest, correct. So since 3.14 was representing pi, let me get a different color here. I'm going to write pi as my first number, okay? We want you to use the original format that they gave you. So that's why we're going to put pi here and not the 3.14. Okay? Alright, so that takes care of this one. Now we are going to go back to the 3.4 and the 3.2 to figure out the next smallest. So is 4 or 2 smaller? The 2 is, so the 3.2 is going to be our next number. And the 3.2 was representing 3 2/10. So I'm going to write 3 2/10. And then the only last whole number 3 that we had here was the 3.4, so that is going to be the next number. And we had that already as 3.4, so we're just going to leave it as 3.4. Okay, so that takes care of all of those numbers. So now we're going to go back to our 4s now. Okay, so our next least number is either going to be 4 or 4.4. So which one is going to be next in line? The 4.0 is, because 0 is less than 4, so that is going to be our next number. And remember, 4 was represented as the square root of 16, which means our greatest number was that 4.4. So in other words, so this is what we needed for least to greatest. Okay. All right, so let me do one more, and then I'll have you guys try a couple on your own. So the square root of 20, notice how the square root of 20 is not a perfect square root. So what we have to do is guesstimate where it's going to be at. So if you guys remember our number line, we have 1, 2, 3, 4, 5. And if I were to write their perfect square roots above, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. So if I want to figure out what this decimal might be, notice where the square root of 20 would fall. So it would fall in between 4 and 5, and it's kind of somewhat in the middle. So I would approximate the square root of 20 as about 4.5-ish. And we may not even need to approximate it into a decimal. We probably could just say that the square root of number 20 is a number between 4 and 5. Okay, so we're just going to leave it as that. Negative 2 3/5, so I do want to change that into a decimal to help us out. So I'm going to take 3 divided by 5. 5 does not go into 3, so I add a decimal and a 0. So then 5 goes into 36 times. So negative 2 3/5 is the same thing as negative 2.6. Then we have another fraction. So again, I'm going to change that into its decimal form. So I'm going to take 10 divided by 3. 3 goes into 10 3 times. 3 does not go into 1, so I add a decimal point and a 0. And if you notice, you're just going to keep seeing a pattern here. So we're just going to say it's 3.3 repeating. Okay. So 10 over 3 is 3.3 repeating. Next, we already have a decimal, so we're just going to leave it as that. And then our last one is 3 7/8. So again, I want to change that 7/8 into a decimal. So 8 does not go into 7. Add your decimal point and a 0. 8 goes into 70 8 times, because that would be 64. Leave us with a remainder of 6. 8 does not go into 6, so add a 0. And then 8 goes into 67 times. 8 does not go into 4, so once again add another 0, and then you'll see that 8 goes into 45 times. So 7/8 is the same thing as 0.875, so 3 7/8 would be 3.875. Okay, perfect. So now we can start listing these in order from least to greatest. But once again, I would recommend just listing them this way so that it's a little bit easier for us to see. Okay, so there is one of these numbers that stand out right away, and hopefully you guys notice it too. it is this negative, right? We know that negatives are less than positives, and since this is the only negative number, we know that this number has to be first. Okay, so this negative 2.6, in other words, the negative 2 3/5, is going to be that first number. Because it's negative, right? All the other ones are positive, and negatives are less than positives. Okay, moving on. So once again, look in the first column. Notice how we have 3s and 4s. So 3s are less than the 4, so I'm not going to look at this one. I'm just going to look at these. So then you move on to the next column. Which one of these numbers is less than? It is the 3, so that means this 3.3 is going to be the next number, and that was represented by 10 over 3. Okay, then the next number, that's the lowest, is going to be the 3.875, since 8 is less than 9, and that number was represented by 3 7/8. Then our last 3 is this 3.9, so that would be the next one. And then the only number that we have left was this 4.5, or in other words, the square root of 20. So there's our order. Okay, so I want you guys to try 6 and 7, and then you can go ahead and pause the video to try 6 and 7, and then press play when you're ready for the answers. Alrighty, so you guys should have 6 and 7 done. So these were the correct answers. I did try and put the decimal form of fractions and whole number form or approximating form for the square roots. So just see if you got those same numbers. If not, that's probably where your mistake was at. So just make sure you guys go back and double check that. So I do have another video for the back side, so just make sure you guys watch this video and then go ahead and click on the other video for the back side. Thank you.